All right, guys, so let's take a look at how to calculate the greatest common factor of two numbers. So we talked in class that the greatest common factor is the biggest number that goes into both of these numbers evenly, okay? So we talked in class about how we're going to use something called prime factorization to help us find the greatest common factor of these two numbers. And when we use prime factorization, we're going to be setting up factor trees to help us break down these numbers into prime factors. So the first thing that we need to do is we need to figure out what two numbers are going to go at the top of our factor trees. And in this case, it is 27 and 63. So I'm going to go ahead and I'm going to say 27 with my little tree and 63, set up my little tree. Okay. Then I'm going to come over here and I'm only working with the 27. I'm going to ask myself, what can I multiply together to get 27? Okay. Now, any multiplication fact will work, but we know that 3 times 9 is 27, okay? 3 times 9. Now, after we get our multiplication on there, what we're going to do is we're going to look. If we have a prime factor, we're going to circle it. Now, 3 is prime, so I'm going to put a circle around it. 9 is not, so we're going to break it down even further, okay? So I have to ask myself, what can I multiply together to give me 9? I can multiply 3 times 3. Okay, again, we're looking to see, do we have any prime factors? 3 and 3 are both prime, so I'm going to circle both of those. Okay, now that I have broken them all down into prime factors, I'm going to come down here and I'm going to write something called the prime factorization. The prime factorization is just a list of the prime numbers. So we look at 27, and we said that if you multiply 3 times 3 times 3, it'll give you 27. So that's what I'm going to write. The prime factorization of 27 is 3 times 3 times 3. Now, we're going to come over here and do the exact same thing for 63. What can we multiply together to give us 63? Well, we can multiply 9 times 7. We have to ask ourselves, are either of one of those prime? 7 is a prime number, so I'm going to circle it. 9 is not, so we're going to break it down further. What can we multiply together to give us 9? Well, we did that right here. We can multiply together 3 times 3, and they're both prime, so I circled both of them. Okay, so now we're going to go back and we're going to write the prime factorization for 63. In this one, it is 3 times 3 times 7. Now remember, we write prime factorizations in order from least to greatest, just to keep our numbers all organized. So 63, we have 3 times 3 times 7. Okay. Now, the next thing that we're going to do is we're going to take a look at our prime factorizations, and we are going to circle the prime factors that they share. Okay, so if we look at our list, we can see that they share a 3. They share another 3. However, they do not share a third 3, and they don't share a 7. Okay, so if I come over here, I'm going to write out what they share. And looking back at my list, they share a 3 times 3. Okay, to get the GCF from this, all we have to do is multiply. 3 times 3 gives us 9. So the greatest common factor of 27 and 63 is 9. Now you're going to use the same process to solve the rest of these problems. You're going to first make a factor tree, list the factors until they're all prime, list out their prime factorizations, circle what they share. Whatever they share, then we can multiply to get the greatest common factor.